Now let's talk about measuring resistance and voltage. This device right here is a ohmmeter and a voltmeter. So here's how I will measure resistance, or I can measure DC voltage, or I can measure RMS AC voltage. Today I am interested in measuring ohms and measuring volts. So what I have built is a series circuit where I have 4 resistors in series, 1K, 3K, 4K, and 5K. They'll be connected to a 3-volt source, which you don't see yet. In this device right here, this is a Protoboard, and I've connected this circuit on my Protoboard. The way a Protoboard works is every row is an individual node. So this is a node, this is a node, this is a node, and so on. When you cross this plastic barrier, here is a new node, here is another node, here's a third node, and so on. So I have my 1K resistor connected through this node. This is actually the green node connecting to the 3K. The 3K is connected to the 4K at the blue node, and the 4K is connected to the 5K at the yellow node. The 5K is going to be connected to the negative side of my voltage through the black node, which is right here. That's this whole line. And the red node, or the positive 3-volt source, is going to be connected right here. Now, if I want to measure resistance, I am not going to have my source connected because that may end up being in series or parallel with my resistance. So I'm not going to put that there, but I want to just measure my resistors by themselves. So I'm going to touch one side of my lead to one side of the resistor, the other side of the lead to the other side of the resistor, and look, this is 0.987 kiloohms, which is just about 1K. These are 5% resistors, so that's good. Now let's measure our 3K resistor. Touch one side, touch the other side. There's what my 3K resistor looks like. Here's the 4K. Touch one side, touch the other side. There's my 4K, and here is my 5K resistor. Okay, now let's hook up our 3-volt source. The 3-volt source is going to be from 2 batteries in series. I'm going to connect the red side right there and the black side right there to my circuit. All right, now let's measure the voltage across this 3-volt source. I have a couple little pins here that are just going to help me be able to hold my things in place. So here is a little pin that's going to allow me to connect my black lead there and leave it. And here's the other pin that will let me connect my red lead. So I'm going to connect those into the black and red rails on my circuit right here like this. Okay, so I don't want to measure resistance anymore. Now I want to measure voltage, so let's turn it over here. So I am measuring my 3-volt source right there. That's 2.907 volts. Okay, let's probe my circuit. The first thing that I'm going to do is measure the voltage at each of my nodes. So right now I'm measuring the voltage at the red node. See, this is the part right there connected onto the red node. It's right there. That's measuring 3 volts. Now I'm going to measure at the green node. Okay, at the green node, so actually let me write right here that this was 2.909 volts. At the green node, remember I said that was the green node right there? At the green node, this is 2.687 volts. At the blue node, right there between the 3 and 4K, it's 2.010 volts. And at the between the 4 and 5K, at the yellow node, it's 1.138 volts. Down here at the black node, we're back to 0. What I just did was I measured the node voltages. I measured the red node, the green node, the blue node, the yellow node, and the black node. Those are node voltages. The way you measure a node voltage is you plug the black lead of your voltmeter into the ground and you move the red lead to touch each of the nodes that you are interested in. Now let's measure voltage difference. The way you measure voltage difference is you put your plug on one side of your resistor, like right there, and you put your black plug on the other side of the resistor. This is now going to measure the voltage that's across R1. From red here to black there, that voltage is 0.223. We also can say this is the plus side of the red side, and this is the minus side, or the black side. Let's do the same thing for this resistor. Let's measure across R2. So let's put the black lead on one side and the red lead on the other side, just like that, and that is 0.678 volts. Put a plus where your red lead is and a minus where your black lead is. Let's get this one, measuring across our 4K now. That is 0.873 volts, measuring from here to here, plus on this side, minus on that side, and now let's measure across the 5K. Right there, this is 1.140 volts, plus on this side, minus on that. Plus is always the red lead, minus is always the black lead. So what we measured there were the voltage differences. Now let's take a look at what we expect to happen. So we went from our approximately 3 volts, and we're going to have dropped 0.223 volts down to our next node. Is that what happened? Take 2.9, subtract off 0.2. Yep, we've gotten down to about this voltage. Then we're going to have lost another 0.678 volts across our 2. In fact, subtract that off from here. Yep, you got down to the next node. Now subtract off the voltage difference here, 0.87, and that is bringing you to the 1.138 volts at this node. Let's also see how those measurements could work this way. Let's measure the voltage across 2 of our resistors. So I'm measuring across R1 and across R2. What voltage do you expect there? You would expect to see the voltage drop across R1 and the voltage drop across R2. So this voltage difference right there is 0.90, and that's plus where the red is, minus where the black is. That's another voltage difference. What if I measured across 3 of my resistors? Add up the voltages that you originally had across them individually, and that should give you the voltage that's across from R1 all the way over here to R3, plus on this side, minus on that side, it's 1.775. Add those up, see if you got the right number, and then finally, when I measure across all of my resistors, sure thing, I'm back to my 2.9 volts. Now wait a minute, this says 2.915 when I started out with 2.909. Your voltages are not exactly accurate, and your voltmeter is not exactly accurate, so you can already see that I wouldn't be trusting these last 2 digits in this particular measurement between this voltmeter and these voltages. So let's just focus on the first digit, the 2.9, which means let's get rid of this, let's get rid of this, let's get rid of this, and so on. Those are your significant digits. So today we have measured resistance, we've measured node voltage, and we've measured voltage difference.